Section 6.5a is about absolute value equations. It's when you have an equation that involves an absolute value and the variable is inside of the absolute value symbol. To do this, I want to look at a specific absolute value, and that's the absolute value of x equals 5. Now in the past we've learned what absolute value means. It means a distance. Now, I want to write this a different way to show you something. If I say x minus 0, I think you'd all agree that x minus nothing is the same as just x. Well, when you write an absolute value equation of this form, there's a couple things to look at. First of all, this number right here represents a middle value that you put on a number line. And then this number here represents the distance. So by saying the absolute value of x equals 5, what we're saying is the distance from 0 is 5 units. So let's put on a graph what that would look like. If I put a 0 right here in the middle, and I say what number is 5 units away from 0, well, the answer is 5, but also negative 5. So if I were to make this a distance, I would say that these are both 5 units, right? So the distance from 0 is 5 units. That's what the absolute value of x equals 5 really means. So if we put two dots there at 5 and at negative 5, those are the two values that make this true. Now, rewriting this absolute value, I can drop the absolute value, and I could say that x equals negative 5, and I also could say that x equals positive 5. That's how you rewrite the absolute value without the symbol, is you rewrite it equal to the negative, and you rewrite it equal to the positive. Here we have to solve an absolute value sentence, and I'm going to do it two ways. I'm going to do one-way graphing, because that helps people understand what's going on, and the other way I'm going to use doing algebra, making a compound sentence. So here I'm going to do the graphing method. Remember that this number after the subtraction sign represents the middle value on the number line, and this number after the equal is the distance. We just learned that in the last slide. So if I were to graph this, the middle value is going to be a 4. And I want to find numbers that are 3 units away from the number 4. Well, what am I doing? 5, 6, 7. That means 7 is going to be one of my answers, but then I got to go 3 units to the other side. 3, 2, 1. I put 2 dots there. It's 7 and 1. So you can see that the numbers 1 and number 7 could be plugged in here, take the absolute value of that, and the answer would be 3. So my solutions here are 1 and 7. You can see that. But now I'm going to solve this using a second method. I'm going to make a compound sentence. And here's how you rewrite an absolute value equation. You take the absolute value off, and you set it equal to the negative version of the 3. And you also set it equal to the positive version of the 3. So drop the absolute value sign and set it equal to the negative version and the positive version. Now we'll solve them. Add 4. You get a equals 1. Add 4 over here. You get a equals 7. Either way, the answer here is 1 and 7. The answer to my absolute value equation. Here we're asked to solve this absolute value sentence, and we're also asked to graph it. So we're going to use the two different methods that we've talked about. You might notice this absolute value sentence has a plus sign, which is different than the two that we've previously used. I suggest that you should always rewrite these with minus signs, because when you're trying to graph them, the number that's in the middle is always after a minus sign. So I would write plus as minus a negative. That way when you graph this, you know you're going to have a negative 3 in the middle. Now when you actually go to solve it, I would just leave it as r plus 3. So r plus 3 equals the negative version of 10, and r plus 3 equals the positive version of 10. This is one way to solve it using algebra. You set it equal to the negative, equal to the positive, and then solve. Subtract 3, r equals negative 13. Subtract 3, r equals 7. So you can see that the answer is going to be negative 13 and 7. And let's see if that holds up in our graph. We know negative 3 will be the middle number, and we want numbers that are 10 units to either side. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, yep, 7. Negative 4, 5, 6, 7, 8, 9, negative 10, 11, 12, negative 13. So my solution are the two numbers negative 13 and 7, and the graph is right there. Here we're asked to work in reverse. We have to find the absolute value equation that matches this graph. And it's one of the ways that I've showed you the graphing rather than just showing you the algebraic method, because the graphing kind of helps you understand this part. Well, I have two dots. I want to find the unit that's in the middle of these two. So what number is in the middle of them? And it looks like the value 6 is in the middle of them. So 6 is going to be my middle value, and I need to pick some letter. I'll choose X. And remember, the number that comes after the minus sign matches with this 6. I'll use green to help you pick that out. Now the number that comes after the equal sign is the distance. So what's the distance from 6 to 9? A distance of 3, and the distance from 6 to 3 is also, a 3. So the number that comes after is a 3. So looking at that graph, you know that that graph are the answers to this absolute value equation. Here's one more graph we have to find the equation for. I'm looking for the middle value between these. So 1, 2, 3, 4, 5 maybe. 1, 2, 3, 4. Yeah. The number 1 is in the middle. And the distance from 1 to each one of these points is 5 units. So, making my absolute value, you can use any letter you want. I'll use n this time just to shake things up. So n minus the number 1 is in the middle, and that equals a distance of 5. One more thing I want to say about absolute values. You will never see an absolute value equation like this. Well, you might see it, but if you see it, it's wrong. It can't happen. And the reason is because of this negative sign. You can't have the absolute value of something equaling a negative. It's impossible. You can't do it. In fact, if you ever see something like this, the answer would be no solution, because you can't have a negative distance. How can you travel negative 2 units? It doesn't work that way. The distance that you travel is 2 units. It might be to the left, but it's not going to be negative. So if you ever have an absolute value equation that equals something negative, you know that the answer is no solution.